Today we're going to talk about how to use tidyverse in R. Tidyverse is a package that includes a number of different functions. So base R has lots of different functions that are really useful. One of the greatest things about R is that there's a huge community of R users who make all kinds of different functions organized into packages that we can use. A package is just that, just a group of functions. And the one that we're going to talk about today is called tidyverse. Really, there's lots of other different packages that are great as well, but we'll start with a review of this one. So the first thing that you have to do when working with a package outside of base R is to install it. So you just write install packages and then put tidyverse. You notice that I typed that in the console, not in my script, and that's because you only have to install packages the first time you ever want to use them. So that's what I'm going to do here. From there on out, every time I open R, I do have to tell R that I'd like to use the packages that I plan to use. And I often put all of the library or packages that I plan to use that day right at the top of my R script. So you can see that I did that here. So now that I've installed it, we'll go ahead and start to analyze the data. And to do that, we're going to have a pretend experiment where we're interested in deaf students' signing skills and their math skills and whether there's any relationship between the two. That's kind of our research question. And we have deaf students, half of whom are at a mainstream program and half of them are in a deaf school. So we're interested in looking at these data. So the first thing that we do that we'll talk about today is called the pipe. So the symbol is like a % sign and then a greater than sign and then another % sign. And what that lets you do is to take a data frame, pass it through the pipe, do something with it, pass it through another pipe if you want to, and so on and so forth. And that allows you to manipulate data, passing it through these pipes. So the first example, we'll use my data, which I've installed here, and you could then pass it through a pipe and filter it or summarize it or do all kinds of different things. The first thing that we'll do here is just to filter it. So suppose I'm interested in just looking at the data for the mainstream students. I don't want to look at the students who go to a deaf school. So I can do that. My data, pipe, filter, type of class equals mainstream. And I could change that filter so that instead of saying equals, I could say, I want to look at the parts of my data where the students got above an 80 in terms of their ASL score. So you could filter things in all different ways. For example, here, the example here we'll start with is just the mainstream data. So you can see in the console that I've now filtered it, so you only see the students who are in a mainstream program. Sometimes you want to save data like this, a data frame like this, so you can make a new variable. Let's say we'll call it the mainstream data, and then I use that gets symbol that we talked about before, and then I can do this pipe. So I'll use my data, pipe, filter, type of class equals mainstream. And now you can see in the top right of my console, there's a list of the variables or the data frames that I've created so far. We have my data and we also have the mainstream data that I just created, and we can take a look at both of those. The next thing that can be useful is to summarize data. And you can use the pipe for summarizing data too. So you could say my data, pipe, summarize, and then I'll make up a term for my summary and I'll say that I'm summarizing the average ASL score. I could have called it anything, but that's what I'll call it here. And then I say equals, and then I'll put in a function. So the function there is mean ASL score. And if I run that, you can see at the bottom that I've got the average ASL score for all of the students. So now let's try summarizing and filtering, so combining the two. So say I don't want the average for all of the students, I really just want the average ASL score for the mainstream students. So I can do my data, pipe, filter, type of program is mainstream, pipe again, and then summarize and do the average ASL score equals the mean of ASL score. And now what you see here is a slightly different average that's just based on the students who are in mainstream programs. I might not want to completely ignore the students from deaf schools. I might want to compute averages over each group separately, but I want both averages. So to do that, you can use a function called group by. So for example, here you have my data, pipe, group by, type of class, pipe, summarize, average ASL score equals the mean ASL score. And when I run that, you can now get these two different averages. One is for the students who are in a deaf school, and one is for the students who are in a mainstream program. Often I don't want just one type of average. I might want to look at the average ASL score and the average math score. So you could add to my summary here a line that says average math score is the mean of math score. If I run that, you can now see two columns, one for the average ASL score for each group and the other for the average math score for each group. You'll notice here that one of the numbers for math score isn't showing up, and that's because we have some missing data in our data frame. And it's often the case that that a data frame will be missing data. A student might have been sick, not there, we don't have a test score for one particular thing. So you have to tell R how you want to deal with that missing data. And there's a couple of different ways of handling it. One way is to add something to that mean function where I calculated the math mean. I could add a little phrase there saying NARM, so remove the NAs and set that to be true. And what that does is that'll eliminate that one NA value that we have in our data set and recompute that average. And if I run that again, you can see we do have complete averages for both ASL scores and the math scores for both groups. But sometimes I don't want to just delete that one particular score. I might want to get rid of any rows that have NA in them. And so I can do that by adding something to my pipe chain. So I can say my data, pipe, NA omit, and then the rest of the function, the group by and summarize function. That NA omit function will take any row that has missing data and remove the entire row. And if I run that again, you can now see that I've got the average ASL score and the average math score for both groups, and the missing data has been dealt with, and all of those rows have been removed. Sometimes I don't want to just summarize an average. I mean, there's other ways you could summarize. So maybe I want to count the number of students in each type of program. I could do that by saying my data, group by, type of class, and then add a pipe saying I'll summarize, and we'll call it the number of students, and set that to equal n. And what that does is it's going to count how many students there are in each group. Another useful function is arrange. It's kind of like a sort function. And what that does is you'll take my data, again you use the pipe, and you can arrange and then choose which column you want to arrange by, and that's going to show you the data in order of ASL score. So those are from lowest to highest. The other function that we'll talk about today is called mutate, and what that does is it'll create a new column or alter a column by doing some kind of calculation over the data frame. So right now we have ASL scores, they're on a scale of 0 to 100, but suppose I want to convert that to a proportion. I can do that by saying my data, pipe, mutate, and I'll come up with a new name for the new column, and we'll say that that's ASL proportion, and that is going to be equal to the ASL score, our current column, divided by 100. And that will create a new column there that you can see in the console that gives you the proportions. For the rest of this tutorial, I'm going to talk to you a little bit about how to create figures. And we do that in Tidyverse using ggplot. And the way you do it is to write a line of code that says ggplot, parentheses, data equals, and we'll set that to be my data. And then you have to tell ggplot what you want your axes to be. So I'm going to say that the x-axis is going to be equal to the type of program, and the y-axis is going to be the math score. And then I have to tell it what type of graph I want to see. So in this case, I want to see a scatter plot, so I'll write plus geom_point. And that's going to show you that x-axis, you can see the type of school, so the deaf school versus the mainstream program. And then the y-axis is giving you the math scores, and you get those dots, and each dot represents a student. I may also want, instead of just using the dots, I might want to see a box plot to give you the distribution. And so what you can do there, instead of using geom_point, is to use geom_boxplot. You can also do both at the same time, so you could add, in addition to the box plot, you could add geom_point, and now you can see those dots overlaid over the box plots. You can do all sorts of stuff with ggplot. You could change the colors, the backgrounds, the fonts, all sorts of different ways of messing around with it. One interesting function within ggplot is called facet wrap. And what that does is it'll create different graphs for different groups if you have different categories. So, you know, in the beginning we said we wanted to see the relationship between ASL scores and math scores. So if I were to plot that, I would have to change the x-axis here to be ASL score instead of type of program. And then I'm going to go ahead and plot that scatter plot. So that gives you a scatter plot, but now we're looking at all of the kids all together. So if I add a facet wrap, I can separate it out so that I can see the one graph for the mainstream students and one graph for the students in deaf schools. So that's a nice way of seeing different types of plots. Often, I think when you're plotting a figure, what you want to see is really going to depend on your data set and the kinds of questions that you're looking at. So I recommend taking a look. There are all kinds of resources out there to show what happens if you make various modifications, and all the various modifications you might want. You could add text to a graph, you could change the colors, you could change all kinds of things. But this is the basic structure of a ggplot graph, is just what I've shown you here. And all you do there is specify what type of graph you want to look at, whether it's a scatter plot or a bar graph or a box plot. So I hope that was helpful. Thank you.